Hello, Kanika. How are you?
Hello, I'm good. How are you?
Good, good. You can start. I'm gonna be on mute to do something, but you can start. And
Okay.
if I
Mm,
have a question, then I will test you.
Yeah, sure. So today we are having again, we deal with VPC. Okay. Yesterday, in the last session, we have seen what is VPC and types of VPCs. Now today we have another concept that we will learn about VPC, that is implied router routing table NAT gateway and internet gateway. And security groups. So there's a diagram, the basic we are following from the last session, similar one. Okay, this is one instance. These are two different instances. This is one availability zone. This is another this is one complete availability zone. This is another availability zone. Right. We know this outer boundary is our AWS cloud. This inner boundary, will act as VPC. Okay. This is an EC2 instance. Okay, here we have applied a NAT gateway. Because it is a public subnet and public subnet contains NAT gateway. IP of this subnet is 10.0.0.0/24. Right. This NAT gateway and this instance Here we have a router that is attached, a virtual router. It is not physically present, but the work it does do is of a router. Okay, and this is our private subnet. The IP of the private subnet is 10.0.0.1.0/24. Okay, this is one instance. This is another instance. And these two instances are internally connected. This is availability zone, you can say B, and this is availability zone A. Now, after this, this red box is our complete VPC. The IP of VPC is 10.0.0.0/16. Okay, and the outer box that we have is our region, complete region. Inside we have created our VPC. Now we have to connect this instance with this router. Then we have to connect this NAT gateway with this router. Okay, similarly, we have to connect this instance and this instance, both with this router. Okay, and outside this AWS region, you will find another router that has been applied. This is a router. Okay, and this router is a internet gateway. Okay, this router gives the internet gateway path, and you can, using this router, you can connect to internet. Okay, then we have two tables. Okay, these this is known as the routing tables. Okay, and inside the routing table we have destination and the target. Because this routing table belongs to this availability zone, that's why it is known as custom route table. The next table we have destination and target. This belongs to this private subnet. That's why only it will have one basic target, that is local, means it is already connected to local, and it is also connected to internet gateway because it is a public subnet. So the IP of the local router is 0.0.0/16, IP of VPC, and internet gateway anywhere. Okay, but this, as it is a private IP, it is only connected to the local network, right? And the local network is our VPC. It is not connected to internet because it is a private subnet. And this table is known as main route table. So if we start with implied router and route table concepts, okay, so it is the central routing function. You can observe one thing in this diagram, that this is the complete VPC we have. Okay, this red box denotes the VPC, right? And inside this VPC, this is the VPC we have, and these are the two availability zones. So our router is connected inside the VPC, but outside the availability zone, right? Because it is outside the availability zone, and it is connecting two availability zones together, right? This availability zone instances are also created, attached to this routing table, this router, and the instances of availability zone are also connected to this router. So it is acting as a central routing function, which is able to connect both the availability zones, but it is inside one complete VPC. That's why it is known as central routing function. It connects the different availability zones together and connects the VPC to the internet gateway. So it connects the different availability zones, means two availability zones we are connecting, and connects the VPC to the internet gateway. Means this is a VPC, and outside this VPC we have the internet gateway. So what this router is doing, it is connecting our VPC with the internet gateway. Next, you can have up to 200 route tables per VPC. Means inside a single VPC, this is the VPC, the red box. Inside this VPC, you can have 200 routing tables. Here only we have two because we have only two availability zones, but you can have 200 routing tables inside a single VPC. You can have up to 50 routes, entries per route table. Now, inside a VPC, okay, you can have 200 routing tables. And inside one routing table, right, you can have the entries of 15 routers, 50 routers maximum. So here we only have one router and two routers right now. But inside a single routing table, you can have the entry of 50 routers. The next, each subnet must be associated with only one route table. Okay. So what does this mean? When we say that each subnet must be associated with only one route table, right, at any given period of time. At a particular time I am talking about. At different times you can have multiple connections, but when we specifically say that each subnet must be associated, okay, means one subnet. We are talking about one subnet that we have created should be associated with only one routing table. Okay, it can't be there that two routing tables have the similar address. Okay, means the subnets have the information in two different routing tables. So say if you have inserted the information of this subnet into one routing table, and again you have entered the information of this router in second routing table. So what happens? It will automatically remove from this table, and now it is inside the second routing table. Inside you have inserted the subnet. Okay, so at a particular time you can only have connections with the routing table, means only one subnet. Information of a single subnet can only be there inside a single routing table. No two routing or multiple tables can have the information about a particular subnet. If you try to understand from here, so this subnet, this is one subnet and this is another subnet. So the information about this subnet of this public IP 10.0.00, okay, 24, either this information can exist only in this routing table or either in this routing table, but they can't be in the both the tables, either this one or either this one. Similarly, information of this subnet should be either in one table, but fortunately first you have written the information inside the one table, but then you have connected this subnet to the another table also. So what will happen? They will remove the connection from here, and now your information will be in this routing table. I hope it is clear to you. Okay, great. So next thing that we can understand, if you do not specify a subnet to route table association the subnet will be associated with the default VPC route table. Now suppose a condition is there that you have not attached your subnet to any of the routing tables. So what they will do, they will connect your subnet with the default VPC routing table. So say this is your subnet and you have not connected to any of the routing table. So what they will do, they will create a default routing table for you and they will connect your this subnet into this default routing table. But remember that one subnet will be only be present inside a single routing table. No single subnet can be associated in multiple routing tables. Next thing, you can also edit the main routing table if you need but you cannot delete main route table. So I've told you we have two tables here, two routing tables. One routing table name is custom route table that we have created, and this is the main routing table that is given. We can edit it, means we can add multiple values inside this table, but we can't delete this main routing table. Okay, so the main routing table cannot be deleted but can only be edited. However, you can make a custom route table manually become the main route table then you can delete the former main as it is no longer a main route table. So try to understand this. Now what happens, say if you there's a condition applied that you want to delete your main table, means there is some error in the routing table and now you want to delete it. So first of all, what you need to do, you have to create a custom routing table manually. Then what you can do, make this custom routing table the main routing table. Now the custom routing table is the main routing table. So the older one is no longer the main routing table, right? So you can now delete that routing table. What I'm trying to say is, this is your main routing table. You can't delete your main routing table, right? But some error comes and there's a condition that it is very much required that you need to delete the main routing table. So what you can do is you can create a custom routing table, right? And this you need to create manually. Okay. Now what you can do, you can assign this as your now as a main routing table. Main routing table it is now. Then as it is your main routing table, this is your main routing table now. So this is no longer a main routing table. Now it becomes a custom routing table. Now you can easily delete it. So this is the process if you want to delete your main routing table in any case. Getting it? Next, you can associate multiple subnets with the same routing table. Okay. So what they are saying that you can associate multiple subnets with the same routing table. Means you have created a routing table. Here you are giving this 3 subnets, subnet 1, subnet 2 and subnet 3, right? So you can, what you can do using this routing table, you can store the information of all these 3 subnets. This is the information about subnet 1, this is the information about subnet 2 and this is the information about subnet 3, both inside a single routing table. But what we have learned before, that a single subnet cannot have multiple routers, right? So learn this difference, don't get confused. Okay, means I am trying to say that multiple subnets information can be taken inside a single routing table, but a single subnet cannot have information inside 2 different routers. This is not possible and this is possible. So what you can do, inside of creating these two routing tables, what you can do, you can create a routing table, a single routing table, right? And you can store the information of these routing, subnet 1 inside this and subnet 2 also inside this. This is possible. Getting it? You understand the difference?
Yes, I understand the difference. Okay.
Now we have completed this router part. Routing table and router part is complete. Now let's start with internet gateway. Just give me a second. Internet gateway. So you can see the internet gateway here in this diagram. So I'm following a single diagram so that you get the understanding that actually how everything is there inside the VPC environment. How every router is connected to another router. So now you can see we have to connect this router, the central router, that is implied router, with the internet gateway. So these two are connected now. Now we will talk about this internet gateway. This one I'm talking about, this is the internet gateway which is connecting us to the internet. Okay. So inside the internet gateway, try to understand. And internet gateway is a virtual router. It is also a router. All the gateways are routers. Just remember that. That connects a VPC to internet. Okay. What is internet gateway in short, if you want to understand, which is used to connect the VPC to the internet, is known as internet gateway. Default VPC is already attached with an internet gateway. So if you are using a default VPC that is already given you by AWS people, then it is automatically already connected with the internet gateway. But if you create a new VPC, then you must attach the internet gateway in order to access to the internet. So if you are creating a new VPC, okay, then you should connect your VPC to internet gateway. Only then you will be able to access the internet. Ensure that your subnet route table points to the internet gateway. They are saying that inside the routing table also you have to specify that you are connecting it with the your subnet that is inside the VPC with the internet gateway. So in the routing table also you have to specify that at this port number, destination port, that our target is internet gateway. In this diagram, you can see we have specified it here. Why we have not specified here? Can you tell? Please answer.
Because it is the private subnet.
Yeah, it's a private subnet, and private subnet
They
doesn't
don't have
this
internet connection.
access to the internet connection. So only public subnet has the power to access to the internet gateway. That's why in this table we have specified it.
Okay.
Now the next thing, it performs NAT connection between your private and public IPv4 address. Now, as we know that one we have a public IP address and another we have a private IP address. The difference between the two is then when we require public IP address, when we have to go from inside our network to the outside world. Right? That time we use our public IP address, but from the outside world, if we want to come inside, then we use our public IP address. It is known as outbound and it is known as inbound. Okay, so it acts between the NAT. Now what this internet gateway is doing, it is creating a NAT gateway between the public IP address and the private IP address. Getting it?
Yep.
It supports both IPv4 and IPv6 networks. Either your IP address belongs to IPv4 or IPv6, it is able to access both the IP addresses. Now we'll come to next topic, that is NAT.
Wait, can you go back?
Here.
Yes, support IPv4 and IPv6 is the public subnet you're referring, right?
Sorry?
Are you referring to the public subnet that supports IPv4 and IPv6?
No. IPv4 and IPv6 are the ranges. Okay, ranges of IP addresses.
Mm-hmm.
Okay, IPv4 is the current we are using, means it provides us 32-bit system. Okay, once these are finished, means what happened, there is an association called IAAM which gives IP to multiple organizations. Say you want an IP address, so you will ask IAM to provide you this IP address, right? So 2 raised to power 32 IP addresses we have with us. Okay, And as someone go ask you to get an IP address, this association will give them the IP address from IPv4. IPv4 means IP version 4.
Okay.
Okay.
But it supports both IPv4. What supported?
Means, see what happens. Some of the IP addresses. Now these are what, because now there are multiple devices coming up. More and more networks are getting. So this range of 2 raised to power 32 is getting finished. Now we have moved to IPv6.
Yeah, I know, but okay.
Yeah.
But you were
So the
explaining.
range, yeah. So they will allow the IP addresses which are within the IPv4, and they will also allow the IP addresses which are from IPv6 department. Getting it? Like say, top,
But it's not.
you have
Am I-
taken to 2010. It is giving the IP address from the range of IPv4. In 2040, you have taken an IP address from IPv6. So what they're trying to say that we support both of these systems. Either this belongs to this range or either they belong to this range. Making
Okay. My question is, it's not in the private. We don't have IPv4 and IPv6 in the private subnet, right?
no. Actually, you can create them as a private subnet also. See, what happens? And let you consent the consent. When we talk about IPv4, okay, I told you yesterday also that we have network ID and host ID, right? And it has 1, 2, 3, 4, 5, 6, 7, 8 here, point 2, 3, 4, 5, 6, 7, 8 here, 1, 2, 3, 4, 5, 6, 7, 8 here, and say one range more, 1, 2, 3, 4, 5, 6, 7, 8 here. Okay. So if we talk about, say, we are talking about range of 16. Okay, 16 subnets we are talking about. So what happens? This will become the network ID, right? And we want to divide this is a complete network, single network. Okay, we want to divide it in only two parts. This is one subnet and this is another subnet. Okay, only two subnets we are creating. So what we will do, from the complete host ID part, we will reserve this 1 bit. Okay, this bit will represent the subnet. Either this can be 0 or 1. If it is 0, then it belongs to this subnet. If this is 1, it belongs to this subnet. Now what you can do inside the VPC, you can say assign, okay, this is my private subnet. Or you can say this is my public subnet. So it's up to you that which subnet you assign it as a private and which subnet you assign it as a public. Okay, any IP address, and inside that IP address the subnets you are making. Means what are subnets? Okay, this is a complete organization. You want to divide it into multiple parts, right? Two parts we are dividing, so two subnets we have created. Now you want that this subnet belongs to the public, so we will create a NAT gateway here. You want this to be private, you don't assign a NAT gateway here. So in this way, any IP address or any subnet can be made public or private. Making sense to you?
I'm gonna repeat my question.
Okay.
In the private subnet, I choose the private subnet. because it is private, when I just get an instance in the private subnet, the instance doesn't have a public IP because it is private in the private subnet. It's not assigned. It's not assigned an IPv4, and the instance doesn't have an IPv4 and IPv6, right? Because I choose it to be in the private subnet, and I choose it to be private. Am I right?
See what happens, you are getting confused. Private doesn't mean that you don't have a subnet or IP address. You will have this IP address, but this IP address inside a subnet, okay, will be only visible to you. The only difference between public and private is this, that both will have the IP addresses, okay, but this IP addresses will belongs only to you, and this will nobody from the outside world can see. Okay, now either it can be IPv4 or it can be IPv6. Getting it? There is no such thing that you don't have an IP address. If you don't have an IP address, if you don't have an address.
I know that I have a private IP, but okay, so what you're trying to say is that the IPv4, IPv6 is just a range, right? A range of IP
yes, they
address.
are just a number. They are just the ranges. Say that it belongs to 0 to 232. This is a range. Means from 1 to 10 is
okay.
V6, V4, and 10 to 100 is IPv6.
Oh.
They can either be public or they can either be private. They also
okay.
They can be public, they can be private.
Oh, got it. Got it. Okay, I understand better. Yeah, thank you.
Can I just repeat what you have understand?
Yeah, so it is the IPv4, IPv6 is the ranges of how many IP addresses I can have. It can be a private, it can be a public.
Yeah, it depends on you what you make that IP address.
Okay, got it.
Making sense?
Yep. Yeah, it made absolute sense. Thank you. I was confused. I thought it was like IPv4, it is a public IP. An IPv6 is a better public IP. But I'm clear. Now I'm clear.
See, what you can do, you can take this IP, okay, and send this IP here and switch this IP to this. As you give this IP to the private subnet, it will become a private IP. If you give this IP to the subnet, public subnet, it will become the public subnet IP. So any number, it depends on you what you want to make it. Right? If you provide it say a public subnet group and a private subnet group is there. So what you say that I assign one, say 10.0.1.0 as a public subnet. So this IP will become the public subnet. What you can do, you don't want it into the public. What you can do, you can put it in a private. Okay, I want this as a private. So it becomes a private subnet. It's like that.
Okay. Yeah. Thank you.
Yeah, it should make you sense very much clearly because it is all interconnected. Networking part is more connected because one network, see this here, all this instance, this internet gateway, these two instances are connected to this router. Then this router is connected to the internet gateway, and this internet gateway gives the access to the internet. Now what happens, this private will not be able to connect with the internet, right? and this public subnet can connect to the internet. Okay, so this is the difference. You need to clear it in the mind. So let's start with the NAT gateway. You can use a network address translation gateway enable instances in a private subnet to connect to the internet or other AWS services but prevent the internet from initiating a connection with those instances. So what see an internet gateway, okay, if you understand from this diagram where it is present, it is here. Okay, NAT gateway is present here, but it has nothing to do with the subnet part. It is made for private subnet one. Okay, if you try to understand it.
Yep.
You can use network address translation gateway, that is NAT gateway, to enable instances in a private subnet. So focus on this word private subnet. So why we use a NAT gateway? So that we can enable instances that are present in the private subnet to connect with the internet or other AWS services, but prevent the internet from initializing a connection with those instances. Now try to understand in this way. This is a website. You have created a website. Okay. And your all this website is in the public subnet, so that anybody that types www.aws.com, right, from the internet, anybody can come to your website, right, because it is connected to the internet gateway, right? This is possible. Okay, now but you don't want that people who are coming from the internet can get the data of the website that they cannot see the data set or the important data that you have inside your website. So what you do, you store that data inside another subnet, and that subnet you have created as private subnet. This is a real-time example. Try to connect it. So all
Okay.
data that is being generated in the website is sent to this data set, but it is private data set, right? It is in
Yep.
private subnet. So nobody from the internet can come and access this private subnet. Nobody can, right? But what is our requirement? That we want this data set inside our website so that any update comes up, update about the any software comes up or anything comes up. So this data can be updated using internet, right? So what we have did, we have created here a NAT gateway. Okay.
Got it. Okay.
Now what this will going to do, this will allow this data set to using the NAT gateway. Okay, you can go and access the internet using the NAT gateway, and whatever you have asked for, they will give you, and the updates will be done, right?
Got it.
But the customer who is outside on the internet can only access your VPC using the internet gateway. They don't have the right to get inside your NAT gateway. So what happens? They can easily check your website, but they can't, but this stops here only. They can't go and check your data set.
Okay.
This
Yeah.
difference
I
about
can.
public IP, private IP, its connection with internet gateway, its connection with NAT gateway.
Okay.
Making sense to you?
Yep.
Great. You are charged for creating and using a NAT gateway in your account NAT gateway hourly usage and data processing rates apply. Amazon EC2 charges for data transfer. Also apply. Now, whenever you are using the NAT gateway, just try to understand this also. Whenever you use a NAT gateway, you don't have to charge only for the NAT gateway, but in addition, you have to charge for EC2 instance also. Because what happened, this NAT gateway this NAT gateway is just creating a network, right? The network between your private subnet with the internet, right? Getting it?
Yep.
But the data processing or the data that you want from the internet, okay, for that you require an operating system, right? For data transferring, you require an EC2 instance. So for data transferring, or you can say data processing, you require EC2 instance, right? So
Got it.
what they will do, they will charge you in total for the NAT plus EC2 instance. The charge is not that much. It is very much affordable and you can easily use it inside a free tier version also. Okay. So it is very easy to use, right? Next, to create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. So try to understand in this way that we know we have to create a public subnet and then we have to create a private subnet. Okay, inside our public subnet, this is a public subnet, and this is our private subnet. We know we are using this NAT gateway. Okay, we are using this NAT gateway to connect it with the private subnet, right? But a NAT gateway can only be created inside a public subnet. It cannot be created inside a private subnet. It is not possible here. So you should always connect your NAT gateway with a public subnet, okay? And the public subnet you should choose in such a manner. This public subnet, there will be multiple public subnets, but you have to choose in such a way that this website or web server you are converting, okay, in which public subnet your data is in. So whenever they will ask you, okay, to which private subnet you need to connect the gateway, first they will ask you that while you are creating a NAT gateway, they will ask you to which public subnet you want to attach. Once you say that I want to attach it in 2.2.0, 10.2.1, in this public subnet, I want to attach my NAT gateway. Once it is done, then they will ask you inside which private subnet you want to attach it, right? So you have to say, see, there will be multiple subnets, private subnets also. So you can specify the address of the private subnet to which you want to attach this NAT gateway. And remember, okay, I'll tell you that later, but this part is clear?
Yep.
Making sense to you? The difference between public subnet, private subnet, NAT gateway should be created?
Yep.
Great. Next, you must also specify the elastic IP address, okay, to associate with NAT gateway. When you create it. So just try to understand about NAT gateway in this way. This is your NAT gateway. 3 things you require while first of all, you need an elastic IP address in which you want, using which you will create your NAT gateway. After creating the NAT gateway, second steps comes in, you have to specify the public, just give me a second. Okay, let's continue. So what we have to do, we are connecting the NAT gateway, okay, So first of all, we have to, while we are creating the net gateway, we have to give it the elastic IP address. After giving the elastic IP address, we have to specify to which public subnet it should reside, right? After that, what we will require is to which private subnet it should be connected. Three things are clear.
Yep.
Then after connecting it to the public and the private and to the elastic IP, now this is very much important. No need to assign public IP address to your private instance. Okay, what they're trying to say, no need to assign a public IP address to your private instance. See, we have seen that we are creating a complete net public subnet, private subnet. Private, inside this private subnet, we will have multiple instances, you can say, multiple EC2 instances we have, because this complete network that we are taking is private. So there is no need for us to assign a public IP address to these instances. As soon as we assign any public IP address, then this internet from outside world will get the access to these instances in the private subnet, and that we don't want, right? We want, okay, we want to make them private. That's why the instances that are inside the private subnet shouldn't be, okay, given a public IP address. Making sense?
Yes.
So after you have created a NAT gateway, you must update the route table that is associated with one or more of your private subnet to point internet bound traffic to the NAT gateway this enables instances in your private subnet to communicate with the internet. What they're trying to say, after you have created a NAT gateway. So till here, we have just created a NAT gateway. What all the things we have inside this NAT gateway? We have only the elastic IP address. Okay. Then you, after creating the NAT gateway, you must update the route table. See, this route table concept I told you is very, very important. Only using this route table, you will get to know to which private, public, elastic, NAT gateway, internet gateway, everything, every network you will have created using the router. Okay, two routers we have. One is the internet gateway router and another one was the central router. Okay, so using these routers, how many connections you have made and where you have made. So this routing table is important. So what you have to do, you have to update the routing table associated with one or more of your private subnet. Means if there are multiple private subnets, so you have to specify to which private subnet this NAT gateway is associated with. Okay.
Okay.
Internet bound traffic to the gateway so that this NAT gateway can associate, right, that to which public or to which private subnet I have to provide an internet connection. Okay, what usually a NAT gateway do, anything, any network is made inside, they will go and check the routing table. They will check, okay, 10.0.1.0 is connected with the NAT gateway. So this requires a internet connection. They will check 10.0.0.0 is connected with the internet gateway. Okay, this requires direct internet connection using internet gateway. 10.0.0.0. This is a local network. Means this is a VPC, right? So in this way, they will check the routing table again and again when they will create any of the network, right? This enables instances in your private subnet to communicate with the internet. This line is clear. As soon as we connect a private subnet with the internet, right? So this is our private subnet. So this is our public subnet. This is our private subnet, right? And this is our VPC. And this is our main AWS, right? Now, what we have done, here we have a NAT gateway, right? Here is our instance. This is our public. This is a private subnet. Having IP 10.0.1.0. And here the IP is 10.0.0.1, say. Okay. Now, what we have to do, we have done. We have associated this NAT with this public subnet, right? As soon as we connect it with this subnet, what will happen in there is a routing table for this private subnet. So they will specify that 10.0.10 is associated with NAT. So as soon as they check this in the routing table, they will allow this EC2 instance to connect with the internet via a NAT gateway. Okay, so as many as instances are there, say there are multiple EC2 instances in a private subnet, now all can get access to the net and using that they can access the internet. Clear?
Got it. Yes.
See, you can understand it with like an example. This is your cabin of your boss. Boss cabin is this. Okay. Outside the boss cabin, inside an office, there is a man. We call it as an assistant or peon. Okay. Who is sitting there. Okay. So any employee of the company. Okay. Any employee of the company want to go to the boss. Right? If they want to go to the boss, first they have to go to the peon, right? What this peon will do, they will ask the boss that I should allow this person, right? And then you are able to contact with the boss, right? So try to understand, this peon is not sitting for the boss, this peon is sitting for you, so that whenever you require the permission to meet the boss, you can easily meet the boss, right? But you require a peon so that they can communicate between you and the boss. This boss have already this peon already have access to the boss. They can anytime meet the boss. But if you want to meet your boss, you have to take the permission of the peon. Similarly, here is the NAT gateway. NAT gateway has already access to the internet, because it is inside the public IP, public subnet. But if you want to get access to the internet, right, you need to go through this middleman, or you can say through this NAT gateway to access the internet. Making sense to you?
Yep.
Clear?
Yeah, it's clear. Everything is clear. I understand that part of the topic.
Okay. So this NAT is basically for the private subnet, but it is inside the public subnet, because they will while you were in the interview, no, they will twist your head like using such questions that uh, you already have internet connection inside the public subnet, then why you are making NAT inside the public subnet? Make it in the private subnet. They will ask you such questions. So you need to be able to answer such questions. That's why I'm explaining you with multiple examples. Okay.
Thank you. Yeah.
So deleting a NAT gateway deleting a NAT gateway disassociates its elastic address, but does not release the address from your account. See, this is in 3 steps. So this is your NAT gateway. This is your elastic IP. Okay. And when you have created a NAT gateway, you have attached this elastic IP, say 10.0.0.1 with this NAT gateway, right? But as soon as you delete this NAT gateway, what happens to this IP?
Remains.
Okay. See, now this NAT gateway is deleted. Now, this elastic IP, you can say, is disassociated. Means it is not associated with anyone. Okay. But because it is inside your AWS account and you have already created it. So what they will do, they will charge you for this elastic IP. Either it is associated with something or it is not associated. They will charge you. So what you have to do, you have to go inside its activity and delete it also, right? So not either deleting the NAT gateway will work. With the NAT gateway, you have to delete its elastic IP also. Then this charge will be cancelled. Otherwise, there will be a address which is dislocated, but they will charge you for that address. Making sense?
Yep.
So this is all about NAT gateway. NAT gateway. So 3 things we have seen till now. Okay. Implied router we have seen, right? Routing table we have seen. NAT gateway we have seen. Internet gateway we have seen, right? So just revise everything in from this diagram.
Okay, let me see.
Check anything is missing from this diagram.
Implied routing.
Yeah, implied router is this one. This router they say as implied router.
Okay. Yeah, I mean everything is good.
Can you just in a summary way can explain me this diagram? What is going on in this diagram?
Yeah, we have a PPC within
So VPC is
one
created.
region.
So just answer me the question. VPC is created in the region or inside a availability zone?
In the region.
Okay.
And then we have availability zone B and A. We have a public subnet. In the public subnet, we have the NAT gateway. In the private subnet, we have two instances without internet connection. But with the NAT gateway, the implied routing,
So what
then these instances, the private instances will have internet.
what implied routing is doing?
It's connecting the NAT gateway.
No. It is connecting the two availability zones.
Oh, okay. Got it.
What is internet gateway doing?
Providing internet to the VPC.
Great. What is NAT gateway doing?
Provided internet with to the private instances.
To private subnet.
To the private subnet.
See, this is instance. This complete box is private subnet. So it is providing internet to complete box, this complete box. Anything inside this box, they will provide them with the
internet.
Now, what are the two tables? What about the two tables that you can see? Two routing tables, how they are different? Hello?
Yeah.
Please explain how these...
The implied routing table is connected to the...
No. It is not implied routing. It is custom route table and main route table.
Okay, so the main route table is connected to the internet gateway.
No. Custom route table is connected to internet gateway. See, this custom table is connected to internet gateway. Main table is not connected with internet gateway because it is associated with availability zone.
Oh, okay.
Right?
Uh-huh.
Because it is connected to this availability zone, that's why it contains internet gateway. It is not connected with this one, right? Making sense? Can we
Yes.
delete the main routing table?
What?
Can we delete the main route table?
No.
If I want to delete, what is the procedure?
You cannot delete the default routing table.
No. If I want that, I want to delete my main routing table. Can I delete my main routing table in any of the way? Is there any way in which we can delete our main route table?
You mean in the management console?
No. I've explained, that what we have to do. See the explanation here. This one. First of all, you have to create a custom routing table. You have to assign this custom routing table as your main routing table. Now, as this is the main routing table, you can easily delete the main routing table because now it is the main routing table is this one. Getting it?
Yeah.
See, any doubts you have, please ask because it needs to be clear, right? Another question I want to have, like, okay, if I have not given any subnet, okay, any of the subnet, any routing table, what will happen? Means
What happened?
this is a public subnet, this is a private subnet. Okay, I have not given anything, any routing table to any of the, means this subnet doesn't has any routing table. What will happen?
I'm not good answering questions.
Sorry?
I'm not good answering questions.
Yeah, you need to practice. So I'm asking questions similar that we have just studied. So what will happen? They will create a default table. And in this default table, they will provide you with this addresses. This subnet information will be in the default routing table. Okay?
Yeah. So if I delete the main, can you repeat that?
Sorry?
Can you repeat what you said?
Yeah. So if we don't have any routing table, we have not assigned any routing table to this public subnet. No routing table we have assigned. So what will happen? By default, AWS will create a routing table here for it. And here they will store the information about this subnet inside this default routing table. Making sense?
That's only if I delete the route table.
No. If you have not assigned any subnet. This is a subnet, you have to assign a routing table to it in which all the information about this subnet will be there. If you have not assigned any routing table by your own, right? What AWS people will do, they will assign a default routing table so that all the
Okay.
this router can be stored in this default routing table. If you will,
Got it.
you will create a custom route table or main route table. But if you don't create any of these tables, then AWS people will create a default table for you. Now making
Got it.
okay. So just let me revise everything to you. So this we have seen what is implied router, right? And the routing tables. Then we have seen these are all about implied routers, right? This, okay. Answer me one question more. That can one routing table have information about multiple subnets?
Yes.
Yes. Okay. So one routing table can have, what's the vice versa? Vice versa is that a single subnet cannot have the informations in multiple routing tables. This is not possible. Clear?
Yep.
Then we have seen, after this, we have seen internet gateway. Internet gateway is used to connect the VPC with the internet. Then public IP address, private IP address we have seen. Then the concepts of subnet we have seen. Then we have started with the NAT gateway, how NAT gateway works. Okay. How NAT gate, how they charge for NAT gateway, they charge in combination with the EC2 instance. Okay. Public subnet, private subnet. Okay. Now let's start with another topic, that is security groups. We have lots of time creating multiple security groups, so it will be very much familiar to you.
Mhm.
Now see in security group. This is our VPC. Okay. Inside our VPC, we have one internet gateway, right? This is our internet gateway.
Yes.
Connected by VPN. Okay. We have a router here. Okay. This is a route table. And this is your NACL subnet 1. And this is the router table for this subnet. And here you have.
Just give me 1 minute.
Yeah.
Okay, back.
Okay. This is the another routing table. And this is the subnet 2. And it is the routing table of this subnet. Okay. Now what happens? This routing table is connected to this router. Similarly, this routing table is also connected to this router. And this router is connected to the internet gateway, as well as this router is connected with this VPN. Okay.
VPN is.
VPN is used for security, virtual private network.
Okay. It's like a firewall.
It is firewall for the VPC.
Okay.
This is your security group. This is your EC2 instance. This is another EC2 instance. And both of these EC2 instances have this as security group. And because it belongs to subnet 1, so the subnet 1 ID is 10.0.00/24. And it is connected to this subnet. Similarly, this is another security group. And this is another security group. This is EC2 instance. This is also an EC2 instance. This is connected with this EC2 instance. And this is connected to with EC2 instance. It belongs to subnet 2 and the IP address is 10.0.1.24, right? And it is connected to this subnet 2. Okay, and this VPC has the ID as 10.0.0.0/16. So now what happens when we talk about subnets and security groups? So these subnets, these security groups, try to understand first the theoretical part. So security groups. It is a virtual firewall that works at ENI level. So first thing, what is security group? It is a virtual private wall. Okay, virtual private wall means without this wall, you cannot enter to ENI level, means the end line level. End line level can contain either EC2 instances or any other AWS services. So if anybody wants to access the EC2 service or ENI level services, they have to first cross the security group. Similarly, this is shown in this diagram. If you want to access these security groups, these EC2 or ENI levels, say it is an ENI levels or ENI levels. So all the services of ENI levels will come into it. So if they want to access these ENI services, they have to cross this firewall of security groups. Without that, no router or internet gateway can access these ENI services. Okay. Up to 5 security groups per.
ENI is Elastic Network Interface.
Yeah. So any service that is inside that ENI, you can easily understand. You have to, if anybody wants to access that interface, they have to go to the firewall of security group first, right? Up to 5 security groups per EC2 instance interface can be applied. So for EC2 instance, for per EC2 instance, 5 EC2 groups can be assigned. Can only have permit rules cannot have deny rule. So this is very, very much important. Okay, just remember it. What you can do, that this is the EC2 groups. EC2 instances, EC2 instances. Okay, what you can do, you have the permission to apply a security group here. that, okay, in these two EC2 instances, security groups needs to be there. But you can't remove a security group that is already attached with the EC2 instance. You can't deny, you don't have the ability to deny a security group. Okay, you only have the rule to permit the access. Stateful, returns traffic, allowed inbound traffic, traffic is allowed even if there are no rules to allow it. But what I'm trying to say, it is very much stateful, means its state depends on the permit rules. Returns traffic means the number of requests that had been made. So traffic means number of requests. Of allowed inbounds, traffic is allowed even with, now what is inbound in this case? So what happens? There are two things. One is inbound, one is outbound. Inbound means these two subnets, okay, are trying to access these two security groups. This is subnet 1 and it is still trying to access the subnet 2. It is known as inbound request, right? And what is outbound? Outbound means this security group is trying to get out of the region and trying to make from a subnet, getting out of the subnet and trying to make a request, that is known as outbound. Okay, so any request that has been made, either this request being made is known as inbound request and this request is known as outbound request. Okay, so see, the next topic we have is network ACL. It will take us nearly half an hour to complete that topic, right? And I'll revise the security group again to you so that it will be very much clear again.
Yeah, NACOs, you mentioned NACOs? NACL.
Network ACLs, short form NACLs.
Oh, that's for tomorrow, right?
Yeah, because that's a very big topic and needs a great understanding. So
okay, okay, so you mentioned the ENI, which is like a network card inside of where is located inside of the instances, or
it's like a interface. See, it's like this. It is a storage type of instances. So in ENI, what we can do, inside this, we have EC2 instances. So if anybody want to access this EC2 instances, they have to deal with the security groups. Don't go in depth with that interface part. Just understand, if anybody want to access an EC2 account, they have to first cross the firewall of security group. Only then they'll be able to access the data that is inside the EC2 instance.
Oh, okay, got it.
Clear?
Yep.
Doubt you have in the session? Just revise
No.
once. Okay. And let me know tomorrow, right? So I need to ask you one thing, that if you are free tomorrow in the morning session, for you means like, if you are free at 12 p.m. till 4 p.m. this time, are you free? Between any of the time you are free
I
tomorrow?
will be sleeping now at that time. Will be sleeping at that time.
Okay, okay.
That's midnight.
Yeah, it's midnight. Okay. Let me just check one more thing. Any other time you're available? Because for 2 days I need to go somewhere at this particular time only, because in India all the functions happens at this particular time only.
Oh, okay. You can do it tomorrow at the same time. I mean, we can. Well, I mean, if we can have it on Thursday then.
I don't want to break the flow. Like, I don't want it, because it's already been too much time that we are investing. And these holidays, what happens? We skip the flow. Whatever we have learned, this level will be low. Okay, for tomorrow, okay, we will be at the same time 8 to 10, no issue. But the next day, that is day after tomorrow, I think that is 2nd of April, right?
Yeah.
We can have a session anytime else than 7 to 10. So please check for your schedule that instead of this time you are available, 7 to 10, I'll not be available. So any other time you will be able to devote for 2 hours.
Let me see. What about in the morning time? I have to check it out. Okay, I'm gonna check it out.
Yeah, just check and let me know. Okay.
Yeah. Okay.
Okay. Good night. Sorry. Good morning. Have a great day.
Okay. Good night.
Yeah. Good night.
Thank you.
Have a great day. Bye bye.